I'm Dan Sweeney from MathSpec. In the Part 1 video, I discussed acquiring and preparing your data for SPS. In this second part, I will first launch an EC2 compute unit on Amazon AWS, which is like a personal server that you can use that has almost everything that you need to do SPS. I will then process some data files on this Amazon EC2 unit. I demonstrated how to use ProteoWizard MS Convert in Part 1. I will not go through installing WinSCP, but I will discuss using WinSCP to move data files to and from Amazon AWS. So let's start by logging into AWS and launching the Amazon machine image called an AMI that has the SPS software on it. We'll start by going to AWSamazon.com. You will first need an account on Amazon AWS. The orange button on the upper right will start the application process. After you enter the required information and complete the application, it usually will take Amazon 15 minutes or so to activate your account. I'm going to use my account to log in here. To launch a server, I first go to VPC. Every account in Amazon, when you create an account, you'll get a default VPC. You can create your own if you like. There's a button here you can use for that. I'm just going to use the default VPC. And here I can launch an EC2 unit. Okay, the first part of the form we need to fill out here is give a name. Let's call this SPS SPS demonstration. And over here there's something called Marketplace. And this is where our application will be. There are 7,725 applications on AMIs from Amazon that you can use. Okay, I want to use the similar partition screening AMI that I have in my site. Okay, now the next step is to choose, so that's, if you will, the software. I need to choose what kind of computer I want to use here. It's a good idea to use a very fast processor to minimize the total charge for using the application. So I want to use a M5ZN. And I want large. Let's go down another part of the form here. We need a key pair. And what this is, it's a security function, if you will. And you have two keys, a public one that goes on this new server that we're creating, and a private one that I have. And those two keys are compared when there's a login. Now I've already got some key pairs created that I normally use, but I'll just go through creating a new key pair here. Okay, let's call it SPS video. Okay, and for the WinSCP function that I'm using, it's sort of based on PuTTY, so I want to use the PPK type key pair. Create that peak. Okay, now this has downloaded it, and the next step is I want to transfer that from the download folder in my computer to a folder that I normally use to store key pairs, because I don't want to lose this key pair. If I lose it, I may not be able to get back into the server. The next section is the another security issue. I can create a new security group or use one that I already have. Now, the default one allows traffic into the new computer from anywhere. Usually if you create one of the choices is to use the IP address that you're using at the time to create this. If you have a static IP address, that would be ideal, and that's what I use here. So only people that have my private key and also are logging into the server from my IP address can get into this new server. If you're in a large organization, you might have a dynamic IP address, and it may change. So in those cases, you may have to talk to your information services department to get your IP range. But that's what I'd suggest. So I'm going to use a existing security group, number 4. And the last thing, you do need, for this AMI, you do need 30 gigabytes GP3. It's not, you could change this, but I would just go with what the AMI requires. The last part is to launch this instance. And we can go to click on instances, and if we select this, however, you really can't use it right away. It'll take about 10 minutes. It's transferring all the information on that AMI, the programs if you will, from a snapshot to this new compute unit that we've just created, and that's going to take a little bit of time. And then a program that does a cycle and keeps looking for new data will be running at that point. It takes about 10 or 15 minutes. So let's copy the public IPv4 address. Copy that, and I want to launch WinSCP. Okay, I'm going to need to edit this protocol. I call it similar partition screening. Paste. So last time I used it, I had a different IP address, of course. The other thing, I can save that, but I also want to change the key pair. Go to authentication. It's a different key pair last time, so I want to browse, and we called it the SPS video. So now I'm happy with the host name and the key pair. I'm going to log in. And the first time you log into a server that you just launched, it's going to say that it's an unknown server. Should you add its host key to a cache? And you say yes. This is the client side. This is all the folders, and in this particular directory, the folders and files that are on my local computer. And over here is the server that we just created, and it has 4 main folders. So let's go to input. I have a bunch of files here from the second reference. Because this is considered a cloud, you're uploading to the cloud, and over here you can download back to your computer. So let's hit upload. So now it's going to copy all these files over. This is going to take a few minutes, so I will pause the video while that's happening. Okay, so the transfer has finished. It took a little bit over 5 minutes to move these 19 files up to the cloud, and these files, after MS convert, they're about 100 times smaller than the original Agilent data folder, which is about 1 gigabyte. So it would have taken probably about 8 hours had we moved the entire data set up to a server. So the MS convert, not only does it convert from a proprietary software, but it also makes the file size much smaller. Now these will be analyzed automatically. There's a program, a cycle program, that's constantly going around and looking for whether there is data in the input folder. If it chooses a file and runs it, when it finishes the run, it will delete that file, and then it'll go back and find another one. So as each one is completed, it'll be put into the output folder. Now you won't see it if you, let's say this is going to take about 6 or 7 hours to run those 19 samples. But if we log in about let's say 4 hours, the output folder will probably still look empty. So you have to constantly go into remote and refresh. So that's kind of something that's hard to get used to, is that it doesn't necessarily automatically update the folders on the cloud side. You have to do refreshes. So you want to save these input files because they're going to be deleted as they're run. I'd like to talk about one more file called unique analytes. Let me try to open this up here. If you've run the same types of samples before, it has assigned analyte numbers to particular unique analytes, and it has a retention time as well, and the number of times it's seen that particular analyte. So for example, this one, this compound, whatever it is, has been seen 20 times in the past. This can be generated easily from the Access database, and we'll see that later. But if you add that in, so I'm going to close this now, but if we were to move this file over to the input file here, at the end of the run, when it's going to try to assign analyte numbers to these new samples, it will check, and if that analyte designation has already been used, it will keep the same designation. So you don't have to later say, well, run number 1 I had a compound with this molecular weight that eluted at, let's say, 18 minutes. Is that the same as a compound with almost the same molecular weight that's coming out at 18.5 minutes now? So life is short, so you don't need to spend a lot of time trying to compare runs and line up the analytes. If you've seen baking shows, a lot of times they'll prepare a dish and it needs to cook for an hour or 2 hours. When they pop that new dish into the oven, they'll at the same time they'll pull out one that's already done. So I've done something like that, and instead of waiting 6 or 7 hours for these 19 samples to run, I've already put the results in the output folder. So we can move on pretty quickly here. I want to get a new directory for the output. Okay, I'll call this SPS demo. The individual runs, for example, River E replicate 2, we're going to get two files out. One is the summary of the mass spec data, the MS data and the MS data, the isotope ratios, retention times, and then the other is possible from the screening process, similar partition screening. We're trying to see if some of these compounds, if the spectra match compounds in this database of about 240,000 compounds. So we get two for each. So we save all the individual samples, but at the end it also summarizes everything. And these four comma separated value files at the top are really the most important at the end of the run. So I want to take those and download those. Okay, and now the individual ones, if I want them, I can download those, but I'm not that interested in them. Go to accessories. This is the other file that I'd like to download. So this is a template. Now, once you have this template and you've started your database, if you're running the same project, you want to just use the same database over and over again. You can always append more samples to it. And then also, of course, you can export unique analytes out so you can line up the names and retention times. So at this point, I'm going to, so my results are now in this SPS demo folder on the desktop. So I can close out the session. The other thing that I'd recommend is that either under instance state, if you are going to be running regularly, you might want to just stop this instance and you can use it over and over again. Then you don't have to wait as long to generate, it takes 15 minutes or so to generate a new instance. But I'm going to just terminate it. So I will terminate that. And anything that's stored on there that I haven't taken off is gone. So I can close out the Amazon. Thank you for watching this video.